Hi guys, in this video we're going to be reviewing rational functions for your semester final. So something to remember about rational functions, it just means that it's a fraction. And so in this one we did a lot of operations with rational functions, and remember when we multiply, we go straight across. Actually, I'm going to add this part first. So when we multiply, we can cross cancel. That's diagonally cancel common factors. Okay? And then multiply straight across. Okay, when we add, actually I'm going to add this one. Division is multiplication after we keep, change, flip. Okay, so keep the first fraction the same, change to multiplication, flip the second fraction, and then it applies to multiplication. For all of these, it's helpful to factor first for every single operation. Okay, now for addition and subtraction, we need a common denominator. Okay, I'm also going to add when solving, we want to multiply by our least common denominator to clear the fractions. Okay, so there's some notes of reminders of like how to do operations and then how to solve. The other part of this unit was graphing rational functions. So this had to do with all of our different asymptotes. So remember, vertical asymptotes, how we found those is we set denominator equal to 0, okay? To find wholes, common factor in the numerator and denominator. Okay. For horizontal asymptotes, we had 3 cases. So the first case was if degree of numerator greater than degree of the denominator. What that indicated is that there is no horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then there's an asymptote at y equals 0. If the degrees are equal, what happens is we do have a horizontal asymptote at y equals the ratio of leading coefficients. Okay, some other, if I don't have a horizontal asymptote, we have a slant instead. And remember, we use long division to get that. Other pieces here, I'm going to add that to get x-intercepts, set numerator equal to 0, and y-intercept, plug in 0 for all the x's. Okay, all right, so we had simplify and operations, solving with rational functions, and then we had the graphing portion. Okay, so these first couple examples are going to focus on the simplify and operations. So when I want to simplify, I want to combine to one fraction. We want to factor first if we can. There's nothing more that I can do to factor this one. So in order for me to subtract these, I need a common denominator. If you're unsure what a common denominator could be, just multiply the two you have together. So I want my common denominator to be x minus 3 and x plus 2. So this one already has the x minus 3. I need to multiply it by x plus 2. So we're multiplying the top and the bottom by x plus 2. Now, a lot of people see this and they're like, oh, I can cancel the x plus 2's. Don't do that. It gets you right back to where you started. You're going backwards if you do that. Okay, the second fraction already has the x plus 2. We need to multiply by the x minus 3 on the top and the bottom. Okay, once my denominators match, I actually like to write it as one fraction. So we've got 3x plus 2 minus 5 times x minus 3 all over our common denominator. Okay, so now I'm going to simplify my numerator, right, by combining like terms. Again, I cannot cancel anything yet because of that subtraction in between. So I have 3x plus 6 minus 5x plus 15 after I distribute that negative 5 over our common denominator. I'm going to simplify this again. So I've got negative 2x when I combine like terms. 6 plus 15 is 21. There's nothing that factors out of that one, so this is my final simplified answer. And don't worry about distributing your denominator. You can leave it in factored form. One other piece, you guys, is you might be asked for which values make the function undefined. Remember, that is kind of like finding vertical asymptotes. It's whatever makes our denominator equal 0. So in this case, x could not equal negative 2 because that would make this factor equal 0, or positive 3 because that would make this factor 0. So you might be asked about what values could not be included in the domain, and those would be how you find it. Look at what values make your denominator 0. Okay, second example. Okay, I want to factor this one first. And I'm going to zoom in just a little bit more. Okay, I want to factor this guy first. So here I have 4x that I could take out of the top. So I got 4x, and then I'd be left with x minus 1. Okay. On the bottom, numbers that multiply to be negative 3 that add to be 2 would be 3 and negative 1. Okay. I'm going to do the keep, change, flip right now. So I'm going to keep this first fraction as it is. I just have it factored. Changing to multiplication. I'm going to flip this one. So I'm going to factor this and put it in my numerator. So numbers that multiply to be 6 that add to be 1, x plus 3, x minus 2. And on the bottom we have 4x. Okay, so now that it's multiplication, we can do some cross canceling. I could also cancel within the same fraction. So for example, these x minus 1s can cancel. There's no addition or subtraction between the factors, so those cancel. The 4x can cancel diagonally with this 4x, and the x plus 3 can cancel with this diagonal x plus 3. So we are just left with x minus 2. Okay, if we had been asked what x cannot be, it could not be negative 3, positive 1. Those are in the denominator. This originally was a denominator, so it could also not be negative 3 or positive 2. And it could also not be 0. 0 would make this one 0. Okay, you don't have to do this unless they ask for it. I'm just showing that as a reminder. Okay, and that we're not solving here, so we don't have to worry about like these not being a solution. We are just simplifying, so I can simplify all the way down to that expression x minus 2. Okay, solving. Okay, my least common denominator, the 7 is over 1. My least common denominator would just be x minus 2. So what I'm going to do is I'm going to multiply every single piece by x minus 2. So we got x minus 2 times 5x over x minus 2 equals 7 times x minus 2 plus 10 over x minus 2 times x minus 2. So the whole point of multiplying by my least common denominator is it is going to cancel my fractions. This one doesn't cancel anything because there was no denominator. Okay, and so I'm left with 5x equals, I'm going to go ahead and distribute 7x minus 14 plus 10. Okay, so I'm going to subtract my 7x and combine my negative 14 and 10 to get negative 4. Divide by negative 2, so we get x equals 2. This is where it's really important to see what x could not be. So if I look back here, could x have been 2? But if I were to put 2 back in, I'd get a 0 in my denominator. So what this means is this is not a viable solution. So we're just going to say no solution when that happens. If we get a solution that cannot be included in the domain, it cannot be a solution. Okay, last example. Find all asymptotes, holes, and intercepts. Okay, I'm going to factor this first. That's going to be the easiest way to see that. Okay, so if I factor p of x, we have 2 and -1, -2, -1, sorry. That multiply to be 2 and add to be -3. Okay, here we'd get +5, -1. Okay, so here's what I like to do first, you guys. I like to find the holes first. So I see I have a hole right here. So we're going to have a hole at when x is 1. Now we do want to look at what's the y coordinate there. So remember, if I were simplifying this, I would cancel this expression out. And I'd just be left with x minus 2 over x plus 5 as my resulting function. So I'm going to plug into, and anytime I want to get a y value that goes with an x, I just plug the x coordinate in. So we're going to plug in 1 for x. And I would get -1 over 6. So that is the y coordinate of the hole. So I could go plot that point, and I just plot it as an open circle there. So there's my hole. Okay, next we want to find asymptotes. Okay, so if it's a hole, it cannot also be a vertical asymptote. So the other factor that would make my denominator equal 0 would be -5. So that is where my vertical asymptote is. Vertical asymptotes are a line, so we need to write it as x equals, so that we know it's a vertical line through this number. Horizontal asymptote. Okay, my degrees of these were the same, they were both squared, and my leading coefficients were 1. So 1 divided by 1 is 1. Again, it's y equals because it's a line going through 1. Okay, intercepts. Okay, so x-intercept. Set the numerator equal to 0. Okay, so again, if it's a hole, it cannot be an intercept. So we're not going to include this. We're just going to look at our more simplified function. So if I were to set the numerator equal to 0, that would end up being 0 when x is 2. So 2, 0 is an intercept. Again, I'm writing that as an ordered pair because an intercept is a point. Okay, y-intercept, plug in 0 for x. I actually like to do this before it's factored because if I plug in 0 for all these x's, they just go away and I'm left with 2 divided by -5. And again, this is a point, so I'm going to write it as an ordered pair. So if it's on the y-axis, or excuse me, yes, if it's on the y-axis, the x-coordinate 0. If it's on the x-axis, the y-coordinate 0. I think we found everything we needed. Intercepts, holes, asymptotes. Yep, so we got this, and then I'll add the hole down here. Hole was at 1, -1, 6. Okay, that's it for examples, you guys. Thanks for watching.